3 EVs are.
Oh, good. So what are the features they are added? Add ADAS feature, anything?
ADAS is there.
No, ADAS, what ADAS they implemented?
So I think they are trying to build level 3, but I am not sure whether level 3 reached or not. I don't know.
Because most of the thing what I see level 2, mostly level 2.
Yeah, they're trying for level 3, but not up to that. But
level 3 will be expensive, because car price will hijack. Correct? It will increase. It will be jacked up price. Again, selling is a problem. Competitive, you have to compete with it,
That is what.
What is the price range expected these vehicles?
No, not any idea, sir.
No idea.
No idea, sir.
You people design how to. No, very clever. I have seen all automobile company. You ask engineer, no, they say they don't know. Next month they're going to list, sir, we don't know. But you only design. You design. You know each and every bolt nut to price. How you don't know? No, sir. Only the sales people will know. They don't know anything. They are not engineer. You made everything, bolt, nut, forging, every cost you know. How you don't know? But not only you. I have talked with Tata about anybody else. They say we don't know. We are technical people.
No, sir. What happened, sir? All R&D people doesn't know about the price. They know about more about the configuration, how the design is working. The cost.
But no. My question is very. I understand, but configuration, what component, what is new, what the individual component, but all this as you don't know prices, no. Then how you don't know?
Old metal I know, sir, but if you ask for the battery pack, I know the cost.
Yes.
As an engineer, will be R&D division knows everything, no. But anyhow, the company, because they decide based on market rate, what is margin,
yes,
all this. Yeah.
Different,
there are many factors are there. No, that's why making product is easy. Selling is the most difficult.
Correct.
Company. Okay. They had an Indian operation. Further, he was the head. All India operation, he was the head. Okay. But now production, the sales and service they were taking care. He was the something like CEO for all India level. They have some 3 offices. Main office on Chennai. He was looking after that. But the sale, the recruiter, he become after 5 years, he become some designation, say overall manager, something like that. But his salary was lesser than his subordinate, who was a sales manager. Sales manager get more than this man. Right? So they ask means because unless he generates market, you don't have a job. Because this man is not selling anything. His overall control and service, main thing is service. So salesperson after 2-3 years, his salary become close to him or more than him, little bit. That time they said, say sales is the most important. If sales is not, company is not there. I just hear that's nothing more than okay, fine. I think we can start.
Yes, sir.
No, you want to tell something?
No, sir. Just I want to say that.
Okay, thank you. Fine. Okay. So we started about talking about sensors some 3-4 classes before. We saw classification of sensors. Just started from what is the definition of sensor. Correct? Under the definition of actuator, transducer, all these things. And what is an electronic sensor? What are its characteristics?
Classification of sensor.
Yeah, we saw classification. Yeah, we saw the classification different 6 types as I put as a this one. Then we started looking at the different type of sensors. In fact, I just we started here.
Yes.
Started with a capacitive sensor. Then we talked about inductive sensor, LVDT. Yesterday we talked about resistive type. Strain gauge, all those things. And yesterday somebody pointed out a small this one. He is correct. So this is DH by H. That's why this one. Thanks for reminding. But this I corrected while writing. I made a mistake, so I just corrected yesterday. I don't know. Somebody told that in the class. That's good.
Roshan has told that.
Roshan or somebody told, not somebody else. Okay, derivation when you're talking, this point was because I put a DA by something else was there. So he told me, correct? That is correct. Okay. Now, before continuing further type of transducers, I just want to talk a little more about important terminologies and the classification of sensors. Already we saw three types of sensors: capacitive, inductive, resistive type. They are the most important sensor used for measuring device. Of course, we are going to see about the thermoelectric, piezoelectric, and also the photoelectric. These three we are going to see. Before that, I want to talk a little more about sensor classification. Sensor classification we saw here. Apart from this classification, it can be further classified into two types. One is called passive sensors, other one is called active sensors. Passive sensor generally receives energy from the environment, correct? If I want to measure temperature, for example, I have a block, metal block, and it is hot, correct? I want to measure the temperature of this. What I do, I take a thermocouple. Thermocouple junction will be made to touch this block. So the heat from this will transfer to thermocouple junction. So there's a EMF is produced. We know that thermal energy, heat energy is supplied to the thermocouple junction. This is junction. And because of that, the thermocouple end of the wire produce a EMF, which is proportional to the temperature. Okay, that means it receives this one. The thermocouple is called a passive. It is not going to generate any energy and send it out. Okay, so it is going to receive heat energy from the object whose temperature we are going to measure. This is a metal block. The metal block is has some heat that is at a high temperature. Because of that, if I touch this one from here, heat will be transferred. Q is the heat energy transfer. Proportional to heat energy transfer, EMS will produce. That's how we are measuring temperature. So this sensor, the thermocouple TC, is called passive sensor. It is receiving energy and produces a proportional millivolts or output signal. So if a sensor receives, for example, strain gauge is there. Strain gauge is there. What you are doing? We are applying a force on it. So when you apply force, the length increases and area decreases. So resistance changes. Okay, resistance changes. So the change in distance, if you measure delta R, which is proportional to force. Okay. Similarly, for example, you see any other sensor, for example, photo sensor, correct? Photo transistor that we are going to see later. If light falls on photo transistor, this is a transistor, and if you give supply voltage, there will be a current flow IC that is proportional to light intensity. Light falling on the base. This is called a base. This is called as a collector. This is called emitter. If light falls on base, the collector current IC is proportional to beta times light intensity. Light intensity, how much light? For example, 0 to 100 lumens. Light is falling. Accordingly, the current IC will vary. 0 to 100 lumens, it is falling. The current IC may vary 0 to 100 milliamps. So we know that the collector current flowing to the phototransistor, this is phototransistor symbol, okay, and is proportional light intensity. So that means light coming from, I am trying to measure, I have a torch light, correct? I want to see how much light it is producing, how many lumens I wanted to check. For that, I can use a phototransistor. These sensors, thermocouple, all these things are called passive sensors, because to measure the parameter, they are not going to generate any energy, send it out. Those kind of sensors are called as passive sensors. Most of sensors are passive sensors. Thermocouple, correct? Force transfer, torque transfer, light sensor, or humidity sensor. All these things are called as passive sensors. Example, like for example, thermocouple. Other one is called active sensor. In the active sensor, it generates energy and transmits or dissipate across the environment. And the energy generated by the sensor will be reflected back by the objects in the surrounding that will be received by a receiver. Active sensor consists of two parts. One is called as a transmitter, other one is called a receiver. Transmitter, for example, if we have you talked about, because okay, autonomous vehicle, people know the lidar and the radar. Already done, you know that. these devices are ultrasonic sensor, ultrasonic range sensor. These are called as active sensors. What means, for example, if you take a LiDAR, it has a laser source. The laser source generates laser pulses, light pulses. It sends light pulses one after another. Now, there's an object in front of the this one, LiDAR. The whole thing is called as LiDAR. This is my LiDAR. LiDAR consists of two parts. One laser source which emit pulses, light pulses, laser light pulses. Now, this goes and hits an object which is on some distance, and the light will be reflected back. It is reflected back. When reflected light pulses also coming back, this is like this. This is transmitted. Those light pulses will come and hit the receiver RX. That is nothing but a phototransistor. I have phototransistor. That means LiDAR consists of two parts. One laser source which emits laser light pulses. That pulse will be transmitted in this forward direction. It goes and hits the object in front of it. And if the object, if reflects the light pulses, that pulses will be received and hits the phototransistor. This is the phototransistor. So the phototransistor generates pulses, voltage pulses, 0 to, for example, 100 millivolts something. Correct? So whether 200 millivolts or something like that, it generates. Now, once the pulse is received, using this sensor, we can measure the distance. LiDAR is measuring distance D equal to the C multiplied by T by 2. Okay, where T is the time taken. T is the time taken by the laser pulse. Taken by laser pulse. Transmitted by the laser source. Laser pulse to hit and return. To hit and return to the receiver. Okay, so that means your transmitter, for example, we want to represent timing diagram, we call it at T equal to 0. I transmitted one laser pulse for the duration, for example, 1 microsecond. This pulse is traveling because this is time axis, and it went and hit this object and reflected back. It is reflected back after some time. This is reflected pulse. This is the reflected pulse sensed by the phototransistor. This is the pulse transmitted pulse. Now, the difference between these two is called a capital T. They are called time of flight. This is called as time of flight. Time of flight time. That means laser pulse sent by laser source, it traveled this much distance, hit the object, it has returned back. The total time going and coming is called capital T. One that is known, then I can divide it by 2, multiply it by C is called speed of light. Speed of light. So I can find the distance. Using this formula, I can deduct the distance between the LiDAR, which is installed on my car, and the vehicle in front of me. The object is nothing, vehicle in front of me, road. So I can measure the distance. This is how the LiDAR works. Same principle used for ultrasonic sensor and also the radar. Okay. So these sensors are called as active sensor. They have a energy emitting source and also a receiving source. Energy receiving and receiving source or sensor. I can say that receiving sensor which generates the electrical pulse. Then measuring the time between these two, I can find the range. So ultrasonic sensor also does same thing. This is LiDAR, and radar also. Radar also does same thing. So these three sensors are called as active sensor. They generate an energy source, electrical pulse or light pulse or ultrasonic pulse that will be transmitted. If it is reflected back, that will be detected by the detect in the sensor, and then it measures the time duration, and from that it calculates the distance. That is how the range sensor, this is an autonomous vehicle. So these sensors are called as active sensor. Okay. Then next important thing is, these are important terminologies. Hello. Okay. These are the important terminology you have to know when we talk about sensors. First thing is, if you buy a sensor, you should know what is this. For example, I want to measure temperature. Thermocouple I want to buy. Correct, for measuring some parameter. Correct. Thermocouple is a sensor. Correct. Those sensor parameters, what and all you should know. Okay. What is the temperature range it can detect? Correct. You know that K type thermocouple, J type thermocouple, M type, L type, like the different types are there. Some 5 to 6 types. Correct. Chromal, the platinum, rhodium, copper constituent, iron constituent, each one has some range. Okay, so if I tell particular this one, what is the temperature you can measure? What you are trying to measure? Input temperature. For example, I want to measure minus 50 degree to plus 400 degree. This is temperature range. The thermocouple, so this is called the input range. Okay, so the range is nothing but the maximum value minus minimum value. What is the maximum value? 400. 400 minus 50. So it will become 400 plus 50, 450. The input range of my thermocouple has to be 450 degrees centigrade. It measures by minus 50. That is what called the input range of the sensor. Okay, that means, for example, you want to measure exhaust temperature of the engine. Correct? What is the temperature you can expect? Maybe it can start from 0. Room generally will not be minus unless you go to cold countries. So we say that for example, throughout the world you want to measure something. This one I say minus 50 degree centigrade to, for example, 800 degree. Right? That is what the exhaust temperature will vary. When engine is running, never going to be the minus. Correct? Once engine is fired, the exhaust temperature will never be even 0. It will be higher than only. So we can say that it starts from 30 degree or 20 degree. Correct? When the first time when you fire the engine, misfire something, so it can go out to 800 degree exhaust temperature. For safer side, I can say that 0 to 1000 degree. So I need to look for a thermocouple which can measure 0 to 1000 degree. That is called the input range. Okay. Then another thing also is there. It is input range which sensor is sensitive to input parameter variation from what is the minimum value it can measure and what is the maximum value it can measure. That's why I said some thermocouples can measure minus 200 to also plus 1000 degree also. There are thermocouples, correct? Minus 52 plus 400. I think this is copper concentrate, Cu and concentrate combination. When you talk about thermocouple, I will tell you what is the, because thermocouple consider two dissimilar metals having different properties. One is copper. You cannot take two copper wires and make a, this is copper wire, this is copper wire. You form a junction, it is not a thermocouple. There's a combination you have to see. That we will talk about when we see about thermocouples. So that is one thing. Outside the range, the sensor may not be able to respond. Even if temperature increases 500 degree, it cannot detect, because when the temperature varies from 0 to minus 50 to 400 degree, this sensor will give, say, 0 to 50 millivolts. That's what maximum give. When temperature 400 degree, it will give 50 millivolts. If the temperature is minus 3, it will give 0 millivolts. Now, if temperature becomes 410 volts, still the voltage will be 50 millivolts. It becomes 500. Still, beyond that, it cannot produce. That means this sensor cannot measure temperature beyond its range. That's why you need to select a temperature sensor which suits your application. So you should know input range of sensor. Then output range of sensor. What is it? Output signal. I said when temperature varies from 0 to 400, minus 50 to plus 400 degree, my thermocouple generates 0 to 50 millivolts, I told. Right? So this is called as output range. This is called as output range of sensor. This is called as input range of the sensor. Output range is given for input parameter. When input is varying of minus 52 plus the input range is 450. Output range is 50. Correct? It is vary from 0 to 50 millivolts. So they are related. When this is 0, the output is 0. When this is, in fact, 0 means what I'm saying is minus 50. Right? So this is called output range. Output signal sync from given input parameter range. When the inputs is changed from minimum value to maximum value, that's already minus 50 to plus 400. The output is varying 0 to 50. This is called output range. How the sensor output changes corresponding to minimum maximum output is produced. That is called as output range. The third one is called sensitivity of the sensor. Okay, sensitivity of sensor. Sensitivity of sensor is defined as how a change in the input signal produces an output signal. How much change? For example, I told you this sensor range is minus 50 to plus 400. For example, minus 50, it changes to minus 49. What is change in the centigrade? The change is 1 degree centigrade. In that case, the output should be, we know that 0 to 50 millivolts. When there's a delta, I call it delta C or delta T. When temperature varied by 1 degree centigrade, minus 49, minus 49, how many millivolts or microvolts come? For example, it produces 0.01 millivolts, correct? So I say which is nothing but 100 microvolts. This is called as sensitivity. That means if 1 degree centigrade changes in the input side, I will get 100 microvolts or 0.01 millivolt, correct? This is called as sensitivity. Suppose if temperature from minus 50, it goes to minus 48. What is delta C? 2 degree centigrade. It is supposed to produce 0.02 millivolts or 200 microvolts. So for given 1 degree unit, 1 unit of input change, what is the output change? That is what called as sensitivity. Okay. This is also called a gain of the transducer. Correct. Output. What is output variation? When input is varied from delta T equal to 1 degree, delta V output is, for example, 1 millivolt, or it can be 2 millivolts, it can be 3 millivolts, or 0.3 millivolt, whatever it may be, correct? So you higher the output for a smaller this, I say my sensor is highly sensitive. That means when higher is sensitive, I can measure small variation also. I can measure 0.1 degree also, not only minus 50 to minus 49, I can measure minus 50 to minus 49.9 also, if it is able to produce higher voltage. So that means a sensor produces more output voltage for small change in input. We say high sensitivity. Sensitivity generally capital S is mentioned at dou Y by dou X, where Y is the output, X is input. X is nothing but temperature change, and Y is nothing but millivolts coming out of sense. A temperature sensor produce a change in the output, for example, 0 millivolts for every 1 degree. That is called as sensitivity of the temperature for this thermocouple. If 1 degree change temperature, it produces 0.1 millivolts. So if it is given 100 volts, 100 degree, you can know the multiply 100, it become 10 millivolts will get. For 100 degree, the sensor thermocouple will produce this. The next one is what you call a resolution of the sensor. The resolution is the smallest deductible change in the input that can produce a deductible output. Correct? Please see that the sensitivity, this both are looks very a little confusing. Okay. For example, I have my thermocouple. Correct? Thermocouple is actually my sensor, and it produces an EMF. And here I have temperature. Correct? Temperature input, it produces an output. This is plus minus. This, how will you do that? It is going to produce a proportional value. So what I do, I connect it to a voltmeter. Correct? I connect a millivoltmeter. Correct? Millivoltmeter, for example, volt type, what you call analog type meter means you have a scale like this. Correct? So 0 to, sorry, this is 0 to, for example, 50 millivolts it can measure. Okay? There will be a needle. A needle will be showing like this. Then you say that 10 millivolts, 20 millivolts, 30 millivolts, 40 millivolts. So if an input from this is given, right? If input is given, the needle will start deflecting depending on input voltage. Okay. Now, if the temperature change, we said that if 1 degree delta C, delta T, I can say that delta T equal to 1 degree, I say that delta V is 1 millivolt. For understanding purpose, I'm saying. Okay. This is my thermocouple giving. Now, temperature initially 0 degree. Delta T was 0. Okay. Now, the temperature is increased from originally 0. It is now increased to 1 degree. So, delta temperature change is 1 degree centigrade. Now, this produces 1 millivolt. Thermocouple is produced. But how you are going to measure? You are going to use this voltmeter, millivoltmeter. I call it millivoltmeter. Millivoltmeter has a small graduations, correct? This is scale in which 0, 10, 20 like this are. In between, you will say that 5. Marking will have there, small marking will be there. Now, 1 millivolts, that means I am drawing a little bigger. This is my 0 millivolts and this is 10 millivolts marking in this scale. In between, I have something, but generally we will not see anything. But automatically in the middle portion, we know that 5 millivolts. If I give 1 millivolts, my needle, originally it was here, okay, will move very small value. Right? So here there's no marking. You cannot read properly. Whether it is 1 millivolt or 1.2, 0.8, how do you know? Right? We cannot say. Then we can say that only when it goes to this one, 5. I can clearly say that this is 5 millivolts. Okay. Now the resolution of this thermocouple with this multimeter, the millivolt meter. The thermocouple is producing voltage. Every degree change, it produces a 1 millivolt. The needle also moving, but I am not able to precisely locate because the graticles or markings are not clear. So what I will say, when it is 0, if I apply 5 millivolt, needle will come here. I know that this is marking 5. If I give another 5 millivolts, it go to 10. So what is my resolution of this sensor or this measuring temperature measuring system? Not the thermal sensor alone, including the measuring unit with displaced unit. Then only I can say what is the temperature. So here the sensitivity is 5 millivolts. Correct? Sorry, resolution is called 5 millivolts. That's what it is. Smallest detectable change in input that can be detected by output. Output is meter. Correct? So if I want to detect 1 degree change, that means I should have thermocouple same, but only thing I should have meter which have 0, 1 millivolt, 2 millivolt, 3 millivolt, like that. Every millivolt there has to be marking. So if temperature changes this one, needle will go here. Now this meter, the meter is getting thermocouple voltage. This is connected to this meter. Meter is moving. TC plus this meter. Now this is the temperature measuring system. The temperature measuring system resolution is 1 degree because marking is there. Previous one was only 5 degree. In between, I could not really tell. You can tell approximately, it is not precise value. Right? So this now you understand what is resolution, what is the sensitivity of your sensor. Okay. The resolution depends upon the output device or display device. The sensitivity depends upon sensor itself. You got it? Any doubt? No problem. Okay. Then next important thing is what you call a time response or latency of the sensor, which is defined as speed with which the sensor can react to the changes. For example, initially temperature 0 degree. So now I suddenly change my temperature to say 2 degree centigrade. Okay, this is the thermocouple input. I am saying now the thermocouple. That means I have the metal block. Okay, this temperature initially was 0 degree centigrade. Suddenly, somehow, I am a magician. I think like a god, but practically not possible. Suddenly, I am able to raise the temperature, entire block temperature 2 degrees centigrade or 5 degrees centigrade, for example, understanding purpose. Okay, suddenly I changed it to 5 degree. Somehow I made it. How I made it, don't ask. If we heat, it takes time. You know, heat does all those things. Understanding purpose. So, on which I have my thermocouple. My thermocouple is touching it. Correct? So EMF should be there. What should the initial? This thermocouple produce 0 to 400 degree means 0 to 40 millivolts it produces, for example, understanding purpose. Okay. When it was 0, the thermocouple output was 0 millivolts. Now, suddenly I raised to 5 degrees centigrade. Somehow I made. If I draw with respect to time, my input was 0 at t equals 0 second. My input was 0. Suddenly I made it to 5 degree. 5 degrees centigrade, the block temperature increased. Now, if I see my thermocouple output, which is coming out of this wire, correct? It has to be immediately it should go to 5 millivolts, correct? But it will not happen. Instead of that, what will happen? It will increase slowly like this, correct? It will increase slowly like this. Okay. So now after some time, it is time equal t equals 0. This is 1 second, 2 second, 3 second. After 3 second, I see that my thermometer says 5 millivolts, which is equal to 5 degrees centigrade. So this time is called as latency time. Time required for sensor to measure and show the final value. The time is called from which sudden changes happen is called as response time or latency time of the sensor. What do you want? Latency time, I say that TL is latency. What should be the value? You are anybody?
0.
That is why, yes, you should measure immediately. This is your wish. You pray God, like, give me a sensor which has 0 latency. But in the world, universe, you cannot make it. Because why? Anybody can tell why it is not possible?
Sir, because time is always changing and it will take time for the measurement to get converted.
Time is changing. That is the time change different. At
But
the- not
data to
because
get
of-
converted to readable value will also take time, no, sir?
No, I have my display is a digital display. It can show in 0 time.
Okay.
Display is able to show. I have digital display. I said even digital display takes time for argument's sake, for understanding purpose. I said that my display I connected to a meter, millivolt meter. It is response time, correct? Response time is 0. Okay. Still, you cannot make response time equal to 0. Send. I am talking a display is doing, but still it will not show. Why? Temperature. See, this is metal block. Temperature say we said 5 degree. Suddenly made it to is there. Okay. Or for example, metal is already 5 degree. I touched the thermocouple metal block which is on 5 degree. That is same as suddenly increasing temperature. My thermocouple was not touching at T equals 0. And T equals 0, I touch a metal block whose temperature 5 degree. That is nothing but step input. Right? That's okay. Now, how the thermocouple works, already told you. The temperature from the metal block, because of temperature, heat energy Q should be transmitted to the thermocouple junction, right? Thermocouple made up of 2 wire, correct? 2 material. It has some mass, correct? Maybe 100 milligrams, correct? Because 2 wires fused melted, they form a junction having some diameter, say 1 mm, correct? Diameter is 1 mm or 0.5 mm, and it has a cube, correct? Like a cube. Sphere, and it has a mass, correct? So the heat energy Q should be transmitted from the metal block to this, and only when this temperature of the block become 5 degrees centigrade, correct? So this is 5 degree metal block. When the thermocouple touch at T equals 0, it was 0 degree, correct? The heat has to heat will not transfer instantaneously, correct? Heat takes some amount of time from the metal block to move into the thermocouple junction and heat the thermocouple junction to same temperature 5 degree, right? So this temperature 5 degree, it takes time. So the temperature heat transfer is the exponential curve. So because of that only, as the temperature increases, with temperature, the thermocouple junction temperature from 0 degree, 1 degree, 2 degree, it is increasing. So the millivolt also is coming up. That's why in practical this one, it is impossible to have a sensor which has 0 response time or latency. A thermocouple may have latency of 14 seconds for 10 temperature is of, I think it is 100 degree. Anything for 10 degree it takes 14 seconds. 14 seconds is too high. I think 100 degree change something measure or something it takes. So that's the latency. But theoretically, practically, or my wish is I want to have 0. Practically not possible. Then next one is called precision. Precision of sensor. The ability of the sensor to reproduce the same output value for repeated measurement of same input. Okay. What I'm saying is I have my force transducer. Correct? I have a force transducer on which I'm applying a force, FRT. Okay. Now, initially, this force transducer, this is the output, millivolts. It is also generating in millivolts. Initially, it was FRT equals 0. Suddenly, I apply an impulse or pulse. FRT suddenly applied 5 Newton force. Initial 0, that means that time 0 millivolts. Suddenly applied 5 Newton. So, it produces, for example, 50 millivolts. When I first time applied. Now, again, second time I apply sample 1. Sample 2, I made it 0. Again, I apply again 5 Newton force. So, this time it says 49 millivolts. Third time I apply FRT. I made it 0 force. Again, I apply. For example, like this. They call pulsed forces. Correct? 0 Newton. This is 5 Newton. 0, 5. 0, 5. I am giving. For example, I gave 5 times. So, every time, if it says 5 Newton, that is equal to that millivolts, correct? 50 millivolts. Correct? Every time it produces, I say that the sensor is a precision sensor. Every time when I give the same input, that's what it says. Ability of sensor to reproduce the same output. Output I say 50 millivolts. If input is 5 Newton. I did 10 times, 100 times. Every time when I apply from 0 to 5 Newton, it produces 50 millivolts, exactly same. Then the sensor is called precision sensor. Instead of that, apply 50. Next time I give 5 Newton, it gives 49. Next time I give 5 Newton, it gives 51. Correct? So there's a deviation of 1 millivolts. This sensor I cannot say precision sensor. Correct? So for repeated this one, this all. If another thing is, if every time it produces same value for 5 Newton, it is also the sensor is called repeatable. It is called a repeatable sensor. That means the same force, same value. 1 time, 2 times, 100 times. So that is good sensor. Precision also, same value it has to produce. Correct? Repeated same value producing called precision with this one, same into this one. Then accuracy. Accuracy, difference between the measured value and the actual value. Correct? I am applying 5 Newton force. The sensor says 4.9. Correct? Yeah, second time apply, it says 4.9. Third time apply, 4.9. Correct? So what is accuracy? Measurement accuracy, correct? 4.9. Only it can measure. It is less by 0.1 Newton. Okay. Instead of that, for example, I have taken another sensor. They say it can measure 5 Newton. You apply 5 Newton, it gave 5.1. Next time also 5.1. Every time. Correct? So every time it shows 5.1. Both the sensors are not accurate sensor. Why? There's a originally 5 Newton, but this is showing 4.9. This is showing 5.1. Both there's a deviation of 0.1 Newton. If it shows exactly same 5 Newton, applied is 5. Output sensor also says 5 Newton. That sensor is called accurate sensor. But it is yes, please.
So what is the difference between precision and repeatability? Sir? Is the same or?
Almost same. The ability to sample produce same output. Correct? Repeated measurements is called precision and repeatable. Accuracy, what is deviation? Correct? Accuracy is nothing but you gave 5 Newton, my sensor says 4.9, or another sensor says 5.1. Both that's a deviation. Correct? How much deviation is there? Then we say depending on how accurate it is. The difference between the actual input and the measured output is called as accuracy. Okay. The third one is offset. The offset of sensor is nothing output value when there is no input. Correct? I have force transducer. It can measure 0 to 5 Newton. That is force transducer they are told. Now, without force also, if I apply the 0 to 5 Newton, it is supposed with 0 to 50 millivolts. This is the output. But if the sensor, many times what will happen when you buy a new sensor, brand new sensor, if you give 0 Newton, it will give 0 millivolts. If I give 2.5, it will give 25 millivolts. If I give this one, the curve will be input output a straight line. Correct? 0 to 5 Newton, it will produce 0 to 50 millivolts. That's what it is going to do. Okay? So the linear curve. But after using 1 year something repeatable, or if you overload, you can apply only 5 Newton. By mistake, you are repeated applying 6 Newton, 7 Newtons of over this one. What will the sensor will deform? Correct? Sensor itself deform. In that case, if you remove the force also, when I give 0 force, it will not show 0 millivolts. Instead, it may give 5 millivolts or 2 millivolts. That is called as offset. That is called as offset. Sensor out, there's a sensor output even when the input is 0. That happens when sensor become old or overloaded. A good sensor, if you by mistake or inadvertently you overload yourself repeatedly, it can deform this one. Even when 0 input is there, the output will be there. The amount of output for 0 input is called offset. But generally it should be 0. But can you use the other sensor with the offset? Anybody?
Yes, sir.
You can use. Only thing is you should know how much offset is. Correct? There is a correction factor. If there's an option, offset is there, that value should be everything subtracted. Take a correction factor. Correct? That means 0, it gives 5 millivolts. Correct? If I give 1 with this one, it gives 15 millivolts. Give 2, it gives 25. 3, it gives 35. I give 5, it gives 55. Then the sensor can be used. You know that there is a permanent offset of 5. The whatever value comes, you subtract 5, that gives the actual value. So you can use provided the offset is linear. It doesn't vary. When input is changed with 0 to 5, the difference is always maintained. In that case, we can use them. Then third one is hysteresis. Now, if I take a sensor, my input is varying from 0 to, for example, 5 Newton. That's what I input varying from this one. For four-star sensor, it produces millivolts. 10 millivolts, 20 millivolts, 30 millivolts, 40 millivolts, 50 millivolts. So now if I plot the curve, you will have a straight line. So this sensor is very excellent sensor. We call linear sensor. Input output is linear. That's fantastic. Instead of that, sometimes some sensors they have specifically magnetic force or magnetic strength measuring. There's a magnetometer. There are some this one. If you say when you increase the input from 0 to 5 force, correct? Now it goes like this. And then when you reduce the force from 5 to 0, it comes like this. Then we have this sensor is called hysteresis. It is not a linear sensor. It is non-linear. It's not a straight line. And take different path. Upward path, downward path. 0 to 5 Newton, the increases 10 millivolt, 20 millivolt, again it goes to peak at 5 Newton, it goes to 50 millivolt. If I reduce 5, 4, 3 like this, it doesn't come in the same path. Instead, it takes different path. If this kind of path is there, one forward, reverse, that is called the sensor as hysteresis. This kind of sensors are really not good. Correct? It is not good sensors, but there are some sensors with the behavior that you should have. You need to calibrate. The last one is stability. Stability of sensor is the sensitivity factor that other than the measure. For example, I have a temperature sensor, correct? I have thermocouple and I am measuring temperature, correct? Temperature measuring, you are getting. Suppose if I apply some little force, correct? I am applying little force on thermocouple junction. Very small force. For example, I am saying, correct? Because of that, EMF should not change. The output of the sensor should change only when temperature changes. If temperature is 0 to 100 degree centigrade, it will produce 0 to 10 millivolts. That's okay. If temperature is 50 centigrade, it becomes 5 millivolts. Okay. Now, temperature is 50 degree, output is 5 millivolts. At that time, I am applying a force on the this one, that junction, little force. Right? You should not trust. If you apply force, if the output changes from 5 millivolts to 4 millivolts or 4.9 or 5.1, if the output changes, that is not good. I say that system is not stable. The system should measure output to change only with respect to change in the parameter what you are measuring. Force changes only with the force, not with temperature, humidity. The sensor humidity changes, surrounding temperature changes. The output of the force sensor should not change. Correct? If it changes, then that's not a good sensor. We say the stability is not there. Main things affecting stability of sensor is noise, distortion, and environmental temperature, air pressure, something like that. Okay. These are the important parameters you have to note down. What is the time? We have another some more time. Okay. Then another thing is the sensor input output character. Already I talked about. The sensor output can be 4 class types. One is called linear type sensor. That means my input is varying from 0 to, say for example, 10. This is input variation, input. Then my output is varying from 0 to 100, for example. And it is a linear, straight line. Correct? I connect point. When I change this, then curve fit, it is a straight line. That is called linear. This is best sensor. The next one is, if input is varying from 0 to same 10, the output is varying to 0 to 100, but in non-linear phases. They call logarithmic. You can see that here, already we talked about what is called sensitivity or gain of sensitivity or gain of my transducer. What is that? Delta X change. For example, 1 to 2, input is changed. Delta X is 1. Then corresponding output is coming. Correct? This is, for example, 2. It went to 3. Correct? This is 0. So, what is the same? Delta Y equal to 1. So now you can see that here input change by delta X 1 unit, the output will change by 1 unit. But if I come here, this part I cut, the curve is increasing. If I cut this, same delta X equal to 1, the output will be very small. You can see that this is not 1, it may be 0.3, 0.2. Correct? This region, the sensitivity is bad. This region better. As I go here, 0 sensitivity become flat. Correct? If sensor input output is this one, they call logarithmic response. This kind of sensors are not good. Okay, these kind of sensor can be used only up to where it is almost straight line. You can use only up to this range. Beyond this cannot be usable range. This is called as unusable range. They call it unusable range. This is usable range. But sometimes you can use full also. We will see what it is, where it is used. For example, this kind of sensor, logarithmic response, is your ear, correct? Human ear drum is there, no? Ear drum measures the sound, correct? Here you can see that ear drum can human ears, nose, correct? Your smell. These sensors are not this kind of logarithmic. This one advantages is it can measure large range of input. The x-axis will be in log scale, correct? The value is 0 to say 10 log, correct? 10 log input value is this one. Logarithmic scale can be a non-linear scale. As it goes, become this non-linear scale. Output is this one. So I can human here can hear the sound starting from something around, I think 10 dB or 5 dB lowest decibels to up to 120 dB also. But this is too high, but it is too dangerous, not good. Correct? So the maximum this one range, exact range I can tell you, it is a non-linear or logarithmic scale like this. Advantages, it can read wide range of changes from small, because here we have high sensitivity. As you go here, the sensitivity become lower, correct? So the eardrum, there's the eardrum movement. This is the eardrum movement. Even if large change is there, for example, 100 dB to 110 dB, the eardrum movement will be very small. So that eardrum will not get damaged. Still you can hear loud sound. When I come to very small sound, correct? Some birds is singing, correct? You want to hear. So the input range is large. So large output is there. So that means I can, when I want to hear low sound, we want linear like this, high gain. As you go to higher sound, you want to do a logarithmic response. Nature has provided this kind of sensor in nose, eardrum, all this thing, non-linear. That is also maybe needed in your practical purpose. We want to see that. Okay. Then other one is called, the third one is called binary. When input is varied to 0 to 10, the output will from 0, 1, 2, 3, 4, up to 4. Input output is always 0. You can see output is 0. When 4, when it increases, become, for example, it is 5, 0 to 5, suddenly changes. If sensors are for some rate, it is output is 0, from 0 to particular value. After that, any value become 5. This is called a binary with 2. It has only 2 levels. So it can differentiate whether value is less than 4, greater than 1. Correct? This is called a binary EGO. Correct? Exhaust gas oxygen sensor. You are using engine. Correct? It can say whether output engine is running stoichiometric gas ratio, lean or rich. Not exactly. Correct? Any value can detect. It give a binary sensor. Third one is called exponential sensor. In this case, the output is opposite to that. This is positive exponential. This is negative exponential. Negative means it goes like this. Right? So these kind of things will be there. What is the advantage? Each one I have given. Linear response output is proportional input, converting the sensor output into measured parameter displaying easy, because always the gain is constant. Correct? Slope is constant. Easily can display. Our very few sensors. Sorry, missed the word. Very few sensors have this kind of linear response. That is called a zero order sensor, like TPS sensor, potentiometer, traffic position sensor. They all have linear response. That is good. The second one is binary. Already talked about that EGO sensor. The third one is logarithmic exponential sensor. The advantage I told. Okay. I stop here. Tomorrow we'll see some more important characteristic of the sensors. Very important. Correct? What you call zero to first order, all these things. Sorry, I just want to tell one small thing. Tomorrow I am going out. I'll be coming back to institute maybe 7:30 evening. So
Okay, sir.
instead of that, we should have some other day compensate when Thursday or some other day.
Sir, we will have it, Thursday, sir. Thursday, 5 to 6 we will have.
Okay, we'll have 5 to 6. Tomorrow I'm going out.
Sir, please, sir, other batch also, our batch is okay, sir, but number of staff confirmed.
You talk to you talk to him. Fine. Okay. Thursday 5 to 6. 6, we have the class. Tomorrow, no class for minor no. Ashish class will be there. I don't know. Correct?
Sure, sir.
Okay. Give
Thank you,
your
sir.
Give your address. Thank you. See you on Thursday evening 5 o'clock.
Thank you, sir. Thank you, sir.
Okay. Thank you.
Thank you, sir.
Thank you.